to 3, 2. And actually, we're going to do 3, 2 and 3, 3 all together. It's good. It's all good. Yeah. So, 3, 2 is solving by adding or subtracting. And 3, 3 is solving by multiplying or dividing. So it's one step inequalities today. So our goal is to get the variable by itself or isolated. We are going to look at different ways we can write it, but remember, we always want our variable to finish on the left. And then there's one special rule when it comes to inequalities. This is a super important rule. You can put some stars by it. You can underline it, whatever you need to do to remember this one rule. If you multiply or divide by a negative, the inequality sign flips. So part of this rule I'm going to write right underneath here. So let's say I have negative 2x is less than 10. To get x by itself, we would divide both sides by negative 2. But because I am dividing by a negative, my inequality sign is going to flip the other direction. Correct. All right, so here are the 4 things you're going to see today. Option 1 is if I have, let's say, x plus 4 is greater than or equal to 2. And I want to get x by itself. I need to move that positive 4. Well, if that was an equal sign, how would I move positive 4? Subtract it. Guess what we're doing here? Subtract 4. We get x. Our sign stays the same, so greater than or equal to. And 2 minus 4 is negative 2. Now, in addition to solving it today, you're going to have to put it on a number line. So at negative 2, are we going to have an open or closed dot? Closed. Very good. And remember, with the variable being on the left, it goes the direction the inequality sign is pointing. It goes to the right. And again, remember how I said your arrowhead and your inequality sign look exactly the same. And of course, if we graph it, we also have to do interval notation. So interval notation, as I go across, reading it from left to right, I come across this closed dot, which is a bracket, and negative 2. And it goes with this arrow all the way to infinity. Yes, exactly. So that is option number 1 that could happen today. Option number 2. Let's say I have y minus 7 is less than 4. To get y by itself, I have to get rid of that minus 7. How do I do that? Add 7 to both sides. So I have y. Negative 7 and positive 7, they cancel. I still have a less than, and 4 plus 7 is 11. When I graph it on my number line, at 11, do I have an open or closed dot? Open, very good. And this time y is less than, which means this goes to the left. Again, my arrow and equality sign look the same. The interval notation. It starts at the arrow, which is negative infinity, goes all the way to 11, and this time it's an open dot, so that's a parenthesis. All right. So before we get into the multiplying and dividing, let's stick with these two for a couple minutes, do a couple real examples, okay? I'll do two examples in this section. First one, example number 1. I'm going to ask you to solve, graph, and write the interval notation. Let's say I think you guys can handle if I jump into a little bit tougher one. Let's say I have 12 is greater than or equal to 4 plus x. Okay, we got to subtract the 4, I agree. Subtract 4 from both sides. So 12 minus 4 is 8. I still have this beautiful inequality sign, and on this side I have x. Well, remember what I said is we want to write our x on the left. So we're going to take and kind of flip this, right? So I have x, and my inequality sign, the small point, is on the x, so that's the direction it has to go, and then 8. Anybody have any question how I rewrote that? Are we all good with that? That's good? Okay. So now when we graph it, of course, at 8, we have a closed dot because it has that or equal to on it. And it says x is less than, so again, this goes to the left. And then our interval notation starts at that arrow, which is starting at negative infinity. Goes all the way to 8. Because it's a closed dot, we get a bracket. Okay, so this part right here where you kind of have to like flip it so that your x is on the left, this part right here is really, really important. All right, let's go with example number 2. Example number 2 again. I want you to solve, graph, and write the interval notation. So on the front side of your worksheet, that is technically the 3.2. That's where you're adding the subtracting, and that's it. And of course, writing it, graphing it, interval notation. So let's say this time I have negative 4.3 plus w is greater than 5. So what do I have to do to get w by itself? Good. Add 4.3 to both sides. All right. I have w. My sign stays the same. 5 plus 4.3 is 9.3. Now here's the thing today. On your number line, because I did not give you number lines today like I did yesterday, all I want you to do is draw me a line, put a dash right in the middle, and put that number on it, 9.3. Is this going to be an open or closed dot? Open. And our arrow goes to the left or the right? Goes to the right. All I'm looking for the graph. Okay? Then the interval notation starts at that open dot, which is a parenthesis, 9.3 to infinity. Any questions on adding or subtracting? No, we're good? All right. And let's go to multiplying and dividing real quick. Again, that's where that special rule is going to come in. So let's say I had something like this. If I have x over 4 is greater than or equal to -1. I need to get rid of the 4 that's on the bottom. It's dividing x. What do I have to do to get rid of that? Times by 4. So I'm going to times both sides by 4. So I'm multiplying by a positive number, so my sign does not change. On this side, the 4's cancel. I have x is greater than or equal to -1 times 4 is -4. And of course, we're going to graph it, just putting -4 on the number line. This is a closed dot because it is greater than or equal to, and it goes to the right. Again, you'll notice your arrowhead and your inequality are exactly the same. Then your interval notation, of course, starts at this closed dot, which is a bracket, at -4. And that arrow goes all the way to infinity. All right, so that's if we had to multiply to solve for x. Probably got to do a division one. Let's say I have 5x is less than 15. Get x by itself, I have to do what? Good, divide by 5. So I have x is less than 3. On my number line at 3. This time, do I have an open or closed dot? Open, very good. And which way does my arrow go? To the left. You guys are awesome. All right, interval notation, starting at that arrow. Means it starts at -infinity, goes all the way to 3, with a parenthesis for the open dot. Okay? So let me do 2 examples real quick, and then I'm done. All right? So example number 3. Again, I'm going to ask you to solve graph, and of course, write interval notation. Bless you. So let's say I have 4 is less than or equal to k over 2. I'm trying to get k by itself, right? So I need to get rid of the 2 that's on the bottom, or the fraction, which means I'm going to multiply both sides by what? Good. We're going to times both sides by 2. On this side, 2 times 4 is 8. I have less than or equal to. On this side, the 2's cancel. I have k. But my variable's not on the left. So we got to flip it, exactly. So if I read it this way, k is greater than, so I want to make sure I write it that way, greater than or equal to 8. On my number line, at 8, I have a closed dot. And of course, if k is greater than, it goes to the right. My interval notation starts at that closed dot, which is a bracket, 8 to infinity. So again, the hardest part of today's lesson is if the variable is not on the correct side, doing that whole flip thing and making sure you mirror the whole thing the other direction. That is the toughest part. Awesome. All right. Last example then, if you guys think you're doing great. Example number 4. Solve graph and write interval notation. And let's go with how about 4 is less than negative 2/3 x. Figured I better put a tough one up here. It's not really that tough, but it's a tough one. So first we got to get rid of the 3 on the bottom. How do we do that? Good. Times both sides by 3. On this side, 3 times 4 is 12. Less than. Here my 3's cancel, so what do I have on the right-hand side? Good. Negative 2x. All right. So now to get x by itself, I have to divide by a negative 2. When I divide by a negative, what special thing did I say had to happen? Yes, you got to flip the sign. So I have 12 divided by negative 2 is negative 6. Greater than, here my negative 2's cancel, and I have x. Exactly, we got to write it the correct way. Which means I have x is less than negative 6. If I graph that at negative 6, I have an open dot, and it goes to the left. Interval notation would be negative infinity to negative 6 with a parenthesis. Now, real quick, I want to point out something. If we go back up to here, I'm going to kind of do it. You don't have to write this down, but I just want to say there's another possibility here. Here where I had 12 is less than negative 2x. If I wanted to move my 2x to the other side, I could add it to the other side, right? Add 2x to this side. If I did that, I'd have 2x plus 12 is less than 0. Do we agree with that? Then I could really move my 12 to that side. So then I have 2x, oops, subtracting 12, sorry, my bad. So I have 2x is less than negative 12. And then, to get x by itself, I divide by 2. I get x is less than negative 6. So by doing the steps where you move them from one side to the other, I didn't have to worry about flipping my sign at all. So that is another option. You think that way is more complicated? And that's fine. I just wanted to show it as an option so that you guys can see that there's more than one way to do this. Yes, this has more steps to it, but you don't have to worry about flipping that sign back and forth. So it's your call, okay? Any questions at all? Now, you have a couple word problems today, but you can do it. Oops, well, get off of there. Well, how did I get... Huh? I agree. Where in the heck did my... There we go. All right. So...